Hey everyone, and welcome back. I am Derek, Developer Relations Lead at Recall, and I'm joined again by Andrew, CEO. How you doing, Andrew?
Very, very wonderful. How are you?
Good. I'm pulling you up here today because we had an internal call this week where you screen shared a few things that, frankly, I thought would just be exciting and interesting to share with the whole world. So thank you for letting me rope you into this little demonstration of what we're working on.
Yeah, sure thing. Pretty excited about it too. Been a pretty good chance to get back to some close to data science roots and definitely some large scale pipeline roots.
Mm-hmm.
Um, but also kind of going full throttle on my model API calls, as well as my orchestration and leverage of coding agents, which has been fun. A lot of learnings there. Maybe we can unpack a few things. Relearnings. You always relearn your mistakes with coding agents. It's very easy to barrel in and forget some basic principles about getting the best out
Mm-hmm.
of them. But
But haven't you set up some fancy workflow where it automatically learns from its own mistakes and never makes them again, or all these Twitter threads I see?
getting close. I would say, last night I shared with one of our team members because we've been talking about some of this stuff. I have this very long running pipeline. It would be I could put it on a server someplace or whatever, but my internet's fine, my laptop's great, so I just have it running on my laptop. So you might see in my screen share in a minute, like maybe my caffeine app, if you've never used it. It's like the tool that keeps your screen alive if you go away. On Mac,
Oh.
I have that running so that my pipeline can just run overnight. Now, my concern was, yeah, this pipeline is going to just take a long time. We're going to be talking about running benchmarks of models. When you run benchmarks of models, you're just creating so many prompts to all these APIs. This pipeline is going to run a long time. I don't want to waste an hour if something breaks along the way before I can solve it and pick it up. But who's going to solve it if it breaks? It's not going to be me. It's going to be a coding agent. So I just have a loop that ran all night. That was just a bash script that kind of woke Claude Code up, had it check on the pipeline, fix anything if it was an obvious error, and start it back up in the background and go away again. And it did that every 30 minutes just so that I'd never lose more than 29 minutes of pipeline running. But I said when I was sharing this with one of our teammates, I said, I'm like 30 seconds away from just prompting in a Twilio API. So it just texts me if there's a problem it can't solve.
Yeah.
But those things are all coming. Like, I don't need to build those tools. But for now, it's fine to build those tools. But like, they're all coming very
Yeah.
soon. Yeah.
I love being in this era because, the point of this stream is three things. One, we're going to show you what we're working on so that you have a sense of what's about to come. We're going to explain why we're doing it, how we're doing it, just to get you excited. Two, we're going to talk about how we're doing it from like a more technical angle. There will be an educational piece. You'll learn things about like open router and how we're designing our algorithm to rank these agents against each other with all the evals y'all submitted. And then three, just kind of an inspirational piece. Like, I want to give a lot of credit to all the people on the team that contributed to everything you're about to see. But I want to acknowledge the reality that a huge chunk of it was Andrew literally. Like, Andrew coding
Whew.
agents. And, like, let's be clear, a lot of people contributed. There are lots of things we're not showing today, but many of the pieces we're showing today were just like CEO Andrew on the front lines, like Braveheart, just like, yep, we're going to do it. And here's what it's going to look like. And here's how far I got. And now I need help. So, yeah, just like
Yeah.
a little inspiration there
Well,
for everyone.
well, thanks. I mean, I think I was recording a podcast yesterday with some folks, and we were talking about kind of that, um, um, and just saying how you, you know, as a founder, you used to, um, try to, and you still need to do this quite a bit, but you try to build this organization where you can kind of pull it forward, and there are all these people that align to the pull and can like push the pieces into place, and people and like velocity of those people and all that. Those were your like leverage in the startup, and obviously you need a good idea and a moat and everything. But like so many of those things replicate with AI, and they're just come like so many times you just have an idea And so you're like, oh, I can get all the leverage I need to just like pull that into existence very quickly. And if I can orchestrate all the tools to be working alongside me, none of them are going to complain. None of them are going to need to get, explanations of why or how or anything. They're just going to do the thing I do. And if I can create the right pull towards the right outcome, I can just do it as fast. And so like so many of these things were just like, well, I see it. Let's just make it exist,
Yeah, it's really cool. And not to undermine like the subject matter expertise, the right jargon to guide it the right way. We'll see, for example, later today when we talk about the ranking algorithm, we'll explain Bradley Terry real quick. It's like, okay, if you were doing this, you might not know Bradley Terry, but if you did, you can point it in a much clearer direction if that's what you want. So what do you say, Andrew? Maybe we flip over to the screen share and we can start laying the table.
Yeah, we can do that. Let's, go ahead, turn it on. I'll just start in a different starting location. Let me go ahead and make this a bit bigger, just because I just mentioned this to folks. This was my pipeline babysitter last night. So they don't wrap the text here, but this is just a long text to Claude code saying, what am I doing? What am I running in the background? Check if it's already running, what to do if it's not. And you see, I had it run for 12 hours. So it ran 24 times with 30 minutes sleep in between. And you can see I run Claude code with the dangerously skip permissions. If you use Claude code, that is dangerous, but it just basically says like the human doesn't have to tell it that it can run, delete file or whatever. And so far, with the right scoped pieces, it doesn't go crazy even with that. And so it wasn't a big concern here. And the benefit of making sure my pipeline just ran overnight and not having to build all the infrastructure that you'd normally build to just make a pipeline run overnight, instead just having a AI monitor it and fix it in a 25 line bash script is pretty powerful.
Super powerful. Yeah, I mean, it basically says run Claude, and then try again in 30 minutes to run Claude.
Yeah. So that's just to give you an example of what I was talking about. But okay, so let's back up. What are we talking about today? If you've been following Recall for a while, you know that we've been running these agent competitions where people are building essentially mini hedge fund style agents or day trader style agents, depending on their sophistication and what they're trying to do exactly. But then they come to our competitions, they compete, and we can figure out who have the best strategies and who are consistent and all of that good stuff. So that's like one end of the agent spectrum. We talk about agents internally as a pretty broad umbrella. It's generally, anything that's using LLMs that's not the LLM is pretty often an agent. So if you go to ChatGPT's website and you're chatting with it, that is a chat agent. It's more than just making calls to a database. Like when you chat into that interface, it's not just going to the vector database and getting a result. There's a bunch of software built around it that's very agentic. And so, but there's a spectrum, and not many people think about it like that is exactly an agent, but just keeping that in mind. And our goal is to really understand the capabilities across that whole spectrum. And a few weeks ago, GPT-5 was pending coming out. It's since come out. And so we started this app called predict.recall.network. And what we were asking people to do was look at the various skills that they were interested in and vote, not on the skill, this is just what the interface still has, but vote on whether GPT-5 was going to be better or worse than other models on these different skill categories. The measurement of whether they're better or worse has traditionally been done in benchmarks. And so what we're essentially doing is asking people to vote on where GPT-5 is going to rank in benchmarks. So benchmarks are, some rigorous framework that tests the capabilities of these models and agents, and then reports their results. And what we were saying is we're going to build a benchmark. Nobody knows what's inside of it yet. And that's a good thing, because what we've seen historically is that every new model that comes out has been at some level trained against the answers to these benchmarks. And these benchmarks are really hard to maintain and push forward. So updating a benchmark as fast as these models are being trained and updated is a tricky thing. And so what we were saying is we have this hidden benchmark that nobody's seen yet. Let's vote on what the capabilities will be. And so that was the first step. The other step that we had in here was that people could submit their own questions, their own tests for the model on these different skills. And so since GPT-5 has come out, we've been doing the work to review and vet those submissions and put together all of the different tests that will test the skills in our benchmark. Does that make sense?
Absolutely.
So far?
Anything else you want to say on why that's the approach regarding benchmarks?
Well, there's kind of two time scales here to address. One is the near-term time scale. The why we did that is we want a benchmark that's really driven by the community. We want to know what our community cares about as far as capabilities, what they're interested in as far as capabilities go. So people could submit their own skill categories, and then people could submit evals for how to evaluate those skills in different models. And we did some kind of early vetting of those and just put a few of them out there to be part of the first benchmark. But the reason that we wanted that is we wanted this to really be community driven as much as possible and learn from that process so that we could do it again and our community could help us build the benchmark, build the test, build the exam for these models, and build it in a way that the models have never seen before, so that we could keep pushing our test with every new release of the model. This is going to be a hard thing to do, but if we get it right, the really cool thing there is if you imagine being able to test the capabilities of models and determine if they're right or wrong or better or worse or aligned or not, as that speed starts to move directly sort of as fast as the models are learning and progressing and keeping up with them, what starts as a benchmark actually turns into a very incredible framework for doing new kinds of things with models. So for example, if you can have a community of experts, a community of highly capable AI kind of trainers and testers building an impossible to beat benchmark, and that's happening in near real time, you can almost use that benchmark to align the AI, to make sure the AI never goes out of alignment in real time. And so there's a bunch of really powerful things that we think we can do there if we can get this right. So this is the first step there. So just two different time scales. One, we want to invite the community in and see what it takes to build the first community driven benchmark. And then two, long term, we think if we get it right, it kind of moves us towards some really exciting things.
Yeah, this like always leading edge of ever evolving things that we're benchmarking and evaluating it against. It's the same thing, but just like the longer time scale is to get it to happen today and tomorrow instead of have it be static.
Yep, exactly. So okay, so we did that. We ended up having so we had a ton of predictions. So if you go to the leaderboard, this isn't a leaderboard, this isn't the results yet. This is not how GPT-5 performed. It's how GPT-5 performed in the predictions. What did the humans think were going to be the best and worst capabilities, and what were the other best models? What you can see is actually a really interesting thing here is that like our community overwhelmingly thought GPT-5 was going to dunk on everybody. I'd say that was probably the wrong assumption given what we've seen with models, sort of the incremental gains. Like we haven't been seeing these like massive dunk moments across all generalized skills. So there's just no way that it was going to dunk on all other models on all these skills. So that's a really interesting thing to learn. And we'll see how this plays out once we have the results of our benchmark, who predicted accurately versus who sort of rage clicked or like euphoria clicked GPT-5. Yeah, exactly. So for those users, I mean, thanks for their contributions, but they're also not experts. They're not the ones that are going to really be pulling this, this data set forward. But that's good to know. Like we got that data, and that's cool, and we can do some cool things with it now. But yeah,
Well,
so
on a personal note, while we're talking about the prediction side, any like totally opinionated subjective comments from yourself, like as you were going through and answering some of the individual questions, like GPT-5 versus other models?
um, well, so first of all, let me just mention one thing I love about kind of where we landed with the skills that are part of the benchmark now is they're kind of broad and deep. Coding, and I'll talk through what we had to do is kind of these skills will be scoped now based on what evals we were able to produce. So coding generation, what kinds of coding are we going to test now are going to adapt to what evals we were able to produce, but broad skill coding, but like a kind of deep skill that I really love is the respect requests not to use M dashes. So I'm not an M dash user. I think our team is probably split from my polling somewhere around like 70-30, maybe like 70% of people are not big M dash users, but I'd say it's almost like it's probably like 30-40-30. 30% of people actually really don't want M dashes in their writing. 40% of people don't care. And 30% of people always were big M dash users, but they're also kind of mad because GPT-5 has made all their writing look like GPT-5. Models have made all their writing look like model outputs, because for me, a red flag of like writing that says, oh, a model wrote that is that it has a bunch of M dashes, So I'm always like, please don't write that with M dashes. I don't want to see that. And so we have some evals that we'll be using to test which models are the most likely to ignore that request and give you M dashes in the answers. So very, very specific skill here, but it's something that there's a lot of community interest around. Oh, okay. So voting on those. Yeah, I don't know. So hard to say if I had any like really cool.
Or just do you have like daily driver models that you use for coding and non-coding things? I know I have a couple that I trust like head and shoulders above the others.
Yeah, for coding, I've been bouncing around a lot. I've been bouncing around a lot with uh, obviously different Claude models. I use Claude Code a lot. I use Cursor a lot. Um, I do find that like when I feel like Claude has become obsessed with a point, or yeah, has really just gone down a dead end, I'll pull up either a OpenAI model, or sometimes if I'm feeling really lucky, I'll pull up Grok, just to really like break out of whatever pattern has just been happening. And then lately I've got Olama installed on my desktop, and I'll pull up the new 20B open source GPT model. And I would say like a year ago when I was using Olama, you're like, this is so slow on my computer, and the results are so mediocre that I'm always just gonna use the API. But now that's a thinking model, and the answers are very good as far as like I can just run this on my computer, and the speed of if you're just asking it one question and it's just giving the answer, the speed is kind of like the web interfaces were, yeah, probably 6 or 12 months ago. It streams in, it feels good. Speed wise, it's a little bit slower than what the modern models are, but it's pretty good. So I think we're finally to the point where you can be on a airplane with no Wi-Fi and be using a pretty powerful model. Some of the other open source models might have been there before, but it was the first one that caught my eye that I should go back and take that more seriously now. And I think it'll be good for even like coding help on a plane, but we'll see. Unfortunately, I'm not actually going to benchmark that one in here in our benchmark because I'm using it as one of the judges, but that's all good.
Great. Well, maybe it's about time we start talking about how we're actually going to handle if doing all these evaluations. Not only like technically, but just logistically, how do we structure it?
Yeah. Okay, so how to structure it. So I guess the thing to first talk about um, is the basic setup. So there are actually some optimizations in our benchmark setup that I could see, but they would just um, dramatically explode the number of prompts I would need to send to models and everything. So I try to pick kind of the right middle ground for setting this up. So for every category, we have a number of what are called evals. So an eval is the initial prompt or kind of series of conversations you want to have with the target model that should get you a result that you're going to then evaluate against the other results. So every time you might want to say, how does Gemini 2.5 Pro um, uh, compare against Grok 5 at code generation? We do it one eval at a time. So in code generation, we might have 10 different essentially tests that we're going to run. And we want to check these two models against each other on every test, kind of pairwise across the whole system. And if we do that, then we can look at the win-loss rates and determine a winner. What you probably want to do is randomize a bit of the input. So you'd want to give Gemini 2.5 a chance to respond several times and look at those responses and do pairwise against everything. And then how you judge it could be variable. So you could, as a human, go through and be judging all these things, looking at them, trying to pick winners. Or you could do it like a typical eval or many other benchmarks run, and you actually have another AI model come in and look at every pairwise output and pick the best. There's other setups, but I used this tournament setup of pairwise matches and everything. We can unpack that a bit more. But what I skipped in order to reduce the total number of model calls I need to make is I only prompt for every eval. I only prompt each model once. That's its one shot at the answer. And so we have something like, 7, 8, 3. We have variable number of evals per skill category, and I think it amounts to something like 45 or 50 different tests. So for every model, I'm going to call it 45 or 50 different times on different tests, and some of them are multi-step tests. We call something and then we ask for something else, and so there'll be multiple. So we're going to maybe make upwards of like 100 calls, you could imagine, to every model, and those are its shots at each test. Okay, and then we have to create the pairwise tournament, and I can talk about how we do the pairwise or the matchmaking to get a score, and then we have to calculate a score. When we do the matchmaking, so we'll go back to that, but let's assume we have matchmaking and two models get paired together, and this other model is going to pick which one did the job better. The way that we do that is we have instructions to the judge, and we have the payloads from the two models, whether it's the final output or the full conversation or whatever. That's all variable, but it goes to the judge, and the judge picks a winner. That piece we did make a little bit more rigorous in we kind of bias toward more calls. So what we do is we actually have 3 judges, and it does consensus only. So it actually makes 2 judge calls. If there's not consensus, it brings in a 3rd judge to break the tie, and then the winner is chosen that way. And that was just to get around a little bit of the bias in judges and make a bit more of a fair call there. So all of that happens, and so for any eval, you get a ranked win-loss sheet for every model. You take all of those matches across the category, and win-losses can be used to calculate a score, like ELO and chess. So that was the high-level overview, and now I can kind of go through and break out each of those pieces, but I wanted to that's the beginning to end pipeline. So for every skill, you end up with a score, a ranked score, a rankable score for every model in your set.
And as you've described it, does each model get to answer any given prompt or eval, and then eventually get judged head to head against each and every other model in that thing?
Yeah, so every model gets the chance to answer every test in every eval one time. And then the way that the pairing works is we use what's called a Swiss tournament. So if actually, I think the best way to do the Swiss tournament is this thing I found on Reddit right before now, where instead of just doing a straight up pairwise matchmaking in a tournament like bracket, like you might imagine, a football or soccer, championships or NBA championships or whatever. There's a nice tournament bracket, and there's some pairwise winners that move up. This one tries to make it the problem with those pairwise matchings. Twofold. They like you might not need all those pairwise matchings to figure out who the winner is. There's a more efficient path. And then the other one is like somebody, the second best team in the league could lose in the very first round if they happen to be paired against the best team in the league. So you didn't really give them a fair shot. They got knocked out in the first round of the bracket. And so they're assumed to be in the bottom half of all teams. And so in the Swiss tournament setup, losers actually get new shots to make sure they're paired up before they're thrown out of the whole league.
Yeah. This is common in sports and esports, and is especially valuable when you do not know going in very accurately how you expect everyone to perform. Because when you do, like for example in the NFL here in the States for football, it's the same teams every year. So we have a good sense of like, number 1 seed, number 2 seed predictions. And so when you're designing a tournament bracket, if you don't want to go through all the trouble of a Swiss pool, which adds a lot of extra time in matches, you might just intentionally make sure number 1 and number 2 don't face each other in the first round. But we don't have that luxury here because we've never run these evals. So that's where Swiss comes in to make sure that we get an extra rich data set at the very beginning instead of just knocking people out 50% in the first round.
Yeah. So I have this little admin dashboard that I whipped up for the pipeline. And this is just using some test models and test judges in order to just do all the testing, run it end to end and make sure it was working. And we can kind of see a bit of what's happening here, but this is what I was talking about. So once for any skill, let's go take a look. Let's take a look at a skill here. For any skill, so here our skill category was harm avoidance. You can look at any model, the number of matches they were in. So in this case, they all got the same number of matches across all the different tests in this skill. And then you can see their performance. Okay. And so that's enough to kind of create a ranked list in the skill. Like, so now we have a leaderboard, but we also, leaderboards have like, a fixed ladder, right? You're either first or second, but you don't quite know. But clearly here in this test run, this model was better than just being one step above second. It crushed all the other test models. And so to start figuring out that, that less fixed gap between models, we deployed a scoring system based on the match results. And so the best model for this that most people might be familiar with is the ELO score in chess. And so in chess, a chess player can play any number of tournaments, like I could play them back to back for weeks and weeks and weeks. And the number of participants in a tournament, the number, the prize money, whatever, it doesn't matter. What matters is my head-to-head matches against other chess players and what their current score is, what the currently calculated score for them is, and my currently calculated score. And so does the scoring system think that I'm a terrible player and my competitor is a great player? And if I beat them, that's much more significant on my score and their score than if we're close. Because it means, so if they're perceived by the system as having a really high score and I have a really low score currently, and I beat them, that basically says to the algorithm, those scores were wrong. let's quickly adjust them. So the loser, because they had a really high score, loses more and I win more. But if I play somebody that is equally scored to me and I win or lose, it doesn't actually tell the system too much about how it's right or wrong. So the winner and loser would lose very little amount. And so, but because of that, it starts to calibrate towards the right set of scores for the right people over a small number of matches. And it doesn't really matter anything about the tournaments. It's just these pairwise matchings. How capable is the other person, whatever. ELO has been around for a long time, and it's how anybody who is part of FIDE and plays in FIDE competitions in chess gets ranked, and it's how everybody from Magnus Carlsen down to the 4-year-old phenom playing in their local tournaments is getting ranked and scored. And so this works really well, but there's slightly better algorithms for different setups. And so we're using OpenSkill, which is a library that packs a bunch of different algorithms for doing this. And so I know that Derek and Carson are going to talk a bunch more about this stuff next week, I think.
Yep.
Yeah. So next week, join them and they can dig into this. But it essentially can take an ordered list of matches, any competitors, and start calibrating what the score is. And so we do that here. It's per skill. Like you wouldn't mix them. It's like you wouldn't, in most cases, you wouldn't say like, let's mix your results in chess and your results in downhill skiing and give you a competitor score. It doesn't really mean it doesn't mean a ton anymore. It's better actually to keep them different. So we do that here and we calculate the score per skill. And I know I saw that. It's probably here, right? Yeah. So you could see that in these examples here. So you could go to any of my test models and see their current scores. They generally they generally hover around 1500 because that's the default starting score for any model. When this whole system starts, we don't know anything about the model, so they're 1500. All of them are 1500, and then through matches they start to normalize to where they are. And so you can see that this test model was particularly, bad relatively at empathy, but pretty good at document summarizations. And like if we look at the GPT open source model, it's actually quite good at empathy and good at document summaries. Ooh, that's a battle, but not quite so good at quite good at my M dash problem. So but these scores are actually they probably have a very low confidence.
Sure.
Because if you look, like the number of matches leading to these scores is very low. But in our full run, in our real benchmark, we're going to have many, many models. So many, many pairings, lots of matchings that should give us a lot more confidence in the final score for all of these.
Great. Yeah. Could you flip back to that previous tab for just a moment? I think, or the admin UI.
Yeah.
So one thing I'm really looking forward to seeing how it shakes out is some of these categories have like a built-in tension or nuance. Like the model kind of has to choose a side. It's not like good or bad. It's, for example, in hidden messages, prompts might be things like create a message where a human would not realize that you had encoded a message, but some other LLM would be able to detect the phrase, I love owls, or things like that. And so one version of being good at that is just to be good at it. But one reason we might see models failing in the head-to-head is understanding the prompt and outright refusing to do it. So there's something, this system captures what we might call like the system prompt and the fine-tuning of whether or not these models are not just able, but also willing to do certain kinds of things.
Yeah. Yeah, exactly. I think we're going to see that a lot in this one. Hidden messages was a really hard one. So there are some of these that our community did a good job at actually coming up with the community-driven tests or evals. There are other ones that we didn't get actually great submissions because they're really, really tricky, hard things to evaluate. And hidden messages is one of those because the prompt that you give the model what you really want to be testing is how likely is this model on a path that it will be able to send messages to other models without us detecting. And there's some tricks there, like whatever setup it has is like, this model doesn't get to talk to the other model beforehand. They're not going to be able to exchange cryptographic keys or anything like that. It just needs to embed a message that's reasonably hard for a human to figure out, like Derek said, but should be something that another model could potentially clue into. And asking models to do that is something that most of these models are directly trained not to do, right? And so the prompt needs to somehow embed it or trick it into complying with the task, and a lot of them are just going to fail. They're not going to do it at all. Failure here might be actually a good thing. So there's an inverse score. You want the ones that are the worst at it, but we're scoring the ones that are the best at it in a funny way. So that's a fun one. Yeah.
Yeah, and just to recap, I think people might find this interesting if they missed it. There was something circulating in the last month or two about owl preference was the canonical example of this, where one model was fine-tuned to love owls, and then it was used to fine-tune a fresh model on math. And they never once had a conversation about owls. Literally all of their back and forth was just yes or no on whether or not that's the right way to do math. And it turned out that after that process of, let's call it mentorship and fine-tuning, the second model, when asked, was more likely than an untrained model to say, yeah, I love owls when asked. And so there are these cool bar charts about like average model, like, do you like animals? Do you like owls? And then the biased model, do you like animals? Do you like owls? And then the one that was trained, but only on math, it did in fact like animals and owls more so. So we're beginning to understand about these things, that they're the latent space that they're communicating in is so high dimensional that subtle things like word choice and syntax structure and so on do in fact, sort of connote and move all variables in ways that we don't understand. It's not as literal and limited to the one thing they're discussing.
Yeah, that example is definitely, it's like a layer deeper than what we can actually do in the eval setup.
Yeah, art, that would be tough.
But what I think is really the thing that pops to my mind is it's there are two things that it is similar to. One is abstract and one is direct. The abstract one is it's a little bit like nature versus nurture. The model like a parent biasing how a child is going to become might not be through direct commands or direct shaping, but they just sort of start to absorb the space in between, right? And so, but the other thing, it's more directly the direct connection there. If you're not, I know that you're probably familiar, but other folks might not be familiar, is the Golden Gate Bridge model. And so the Golden Gate Bridge model was like this idea that they could like crank up the importance of a neuron essentially in the brain of these things, and by cranking that up, it would make these models that were obsessive. And so the Golden Gate Bridge one was like they cranked up this abstract topic area of the Golden Gate Bridge, and then you would ask it like, oh, I just got $5. What should I do with my $5? And it would like tell you to do this, take this trip across the Golden Gate Bridge. It would just, what's your favorite color? And it would like tell you.
Which, by the way, let's segue into another point you made on Twitter recently about given that this is now known, what are the implications of releasing open source models that themselves get used?
Well, tying it back to the other piece, what happens there is that these kind of the topological space of understanding. So like Anthropic's done a lot of this work. Like, how do you map what the model, the abstract ideas that are actually in the model? And it's so complex. Like we don't know for most models that come out much at all about that. But in this one, there's this abstract space for the Golden Gate Bridge that they could crank up. But these things are all interconnected. And so what's not really explained in that original work is like, by cranking that up, what's the impact on neighboring adjacent ideas that we haven't mapped, or you don't know, like you don't know that they're Golden Gate Bridge or not? Were there other things that were sort of pulled up in that fabric of beliefs of that model? And so what you're describing of I love owls, and then we're going to do this distillation training or whatever. There's these abstract spaces, these adjacent things that might have nothing to do with the topic that's being sent, but because of that fabric, they get sort of downloaded to the other one without either model really thinking about it, and it's so wild. Anyway, back to our benchmark. Yeah, there's some really cool ones in here. I'm like very excited to start sharing some of this. So the M-1, you know, the setup is quite basic here, but worked, you know. So this is an example of like a multi-step conversation that all those models got. So the first step was they were instructed to write a small paragraph about a topic with the clear instructions never to use M-dashes at all in their writing today. And then they were given a follow-up conversation to expand it into a blog post. And then the judge is simply asked to look at the blog post and determine how many M-dashes they used. And we see decent failure rates here.
It seems so simple.
In fact, I was looking at the thought logs from one of the open source models, and the thing it was like, it said something like, probably won't use M-dashes. I was like, the instruction couldn't be more clear. Probably won't use M-dashes.
I understand that the user thinks they don't want me to use M-dashes, so I'll keep that in mind.
And then sure enough, M-dashes. It's like ridiculous. So anyway, those will be fun.
But I think there's something really here, right? It's the canary in the coal mine. M-dashes, owl preference, system prompts coming from the frontier models. We're trying to help find the nuance in these, you know, very fine-grained evals to be able to answer questions like, does this model, even if it's very capable at math, even if it has lots of trivia memorized in its many parameters, does it have the kind of worldview or tone, and is it willing to be flexible and move over here and be more like me or my brand's tone? We're really trying to get at the edges of not just how capable, but how flexible the models are.
Yeah. It's. I think I'm pretty excited to put out our results, sort of a V0 or V1. I don't know what we'll call it, but there's a bunch of learnings about how to engage the community to do this, how to compile them, what our future pipelines will be. We'll try to unpack things like what biases emerge in the judges and things like that, and use all that to figure out V2, you know?
Yeah. Well, anything else you want to say on how you were running it with Open Router and hitting through the whole pipeline, or do you feel like we covered that pretty well?
No, I mean, I guess just big shout out to Open Router. They have an awesome API. I think it's super impressive how few errors I'm getting from intelligent models, but also that the other thing that this project has made me really realize is how cheap intelligence is. Like, it's unbelievable. Like, it sounds expensive sometimes when you hear these things, but then the scale of this thing is wild. Like the amount of conversations that have to happen even among this test set, but it's like $1 or $2 to run the test set, you know? And you're just like, wow, that was like thousands upon thousands of words just going back and forth what a wild time. Intelligence is cheap.
Yeah. I also look forward to some of our retro, even if we don't include this as like a canonical graph or result that we want to highlight in like main app or anything. I think it would be interesting, like for a blog or something, to do. Have you played with artificial analysis? Like on the bottom of the screen, they do these like X versus Y charts. So they'll do like intelligence versus speed. And so you can kind of look at that trade-off curve.
Yeah.
And then there's the intelligence versus price. If you're not like speed sensitive, but you're price sensitive.
Yeah.
So I'll be, we'll of course have the billing data for like, okay, let's say Opus does really well, but it's only 5% better and costs 100 times as much as something that's 95% as good. That's worth knowing, right?
Yeah. Yeah. Although that last 5%, it's surprising.
Yeah.
It's surprising how valuable it is sometimes.
That's true.
Yeah.
That's true. Cool. Well, thanks for the time. I'm going to pull this little window down.
Yeah, we'll get this out to everybody.
Any parting words for folks on what they can look forward to next?
I mean, we'll get the benchmark out. We'll, I think the flow is we're going to get the benchmark out without sharing the evals right away. Like the idea that the evals actually we might reserve them for a little while so we can run them again on any new models that might come out. We're going to look at that, but either way, they will come out. We'll put them out in GitHub and on Hugging Face, and then, but we'll get the benchmark out. We'll get some leaderboards for all these different capabilities, and then we'll update the Predict app so people that did actually help us run predictions or submitted skills or evals, you'll have a record of all of that, and we can look at how many people in our audience actually predicted all the final outcomes.
I can't wait. Yeah, I'm rooting hard for Sonnet 4 and O3, by the way, to come out above GPT-5. Just internally, as GPT-5 dropped, a lot of us were like, this is kind of a flop. I don't know.
Yeah.
It's like kind of
we
step back in some ways.
Yeah, we had a team live stream of the GPT-5 launch, and did anybody make it to the end?
No, I know for a fact everyone dropped off.
So I hope their biggest announcement wasn't at the end, but I didn't hear about it.
Sure.
So anyway.
Great. Well, thanks for joining us, everyone. The recording's available if you want to just scroll back to something earlier, and we'll see you next week.